Thank you, Paul, for the introduction. So let's talk about alternative carbons. But first, very often I'm asked, what consultant are you? What are you doing? So this is my boilerplate. I'm a market scout. So I scout materials to market and predominantly carbon materials, but at the moment also I'm scouting, for example, functionalized BR, functionalized SBR to non-tire markets. I like bringing materials to the market. You might also know me as the business partner and co-founder of Recovered Carbon Black. We're going to talk a little bit about that later. And I quite enjoy content creation. I bring Recovered Carbon Black onto YouTube and LinkedIn. And I started agency services and media production for companies in Recovered Carbon Black. Okay, so let's talk about carbon black first, because this is the Carbon Black Conference. Then I will cover methane blacks, recovered carbon blacks, and biofillers. So when I moved to Berlin in 2017, I was quite surprised to find a former carbon black site in my backyard that used to be an active gas black site. And this is a table I don't want to go through, it's too small anyway. But this is from the CIA Strategic Bombing Survey, where German carbon black sites, there were 22 carbon black sites. Germany in the 30s wanted to become independent from US channel black and develop new technologies. And the reason I'm showing this is there's several ways they found. One was impingement, electric arc, and several processes. So I don't go into detail. But this is setting the scene for asking ourselves, what could be processes making carbon black? Now, terminology. I love this norm, this ASTM norm 3053. What is carbon black? Elemental carbon, of course, aggregates of aciniform, grape-like morphology or structure, uniform primary particle sizes, uniform aggregate sizes are all important. For me, as a consultant and market scout, the most important is it's an engineered material. It is purpose engineered for its application. And that will be very important for the other products, the other carbons I will present about in a moment. What is the status quo? So we already said the furnace process is producing 95% of the carbon black supply. It is very flexible. We have 3 major carbon black oil feedstocks. The yields are depending on the products we are producing, also on the state of the technology, and maybe the yields we can model between 51 to 72%. 72 is a higher yield for maybe semi-reinforcing, 51 is a bit more elaborate carbon black. We get a lot of energy from tail gas. Most of the carbon black production sites are power plants as well. For some, actually, the power is the main product and carbon is only the byproduct by contract. And what is clear to say, no other process is as flexible as the furnace process. So we got 40 different types of carbon black ASTM grades. And this is just the ASTM grades, because we have a lot of specialty grades that go, let's say, beyond the 100 series, racing grades, conductive grades, or, for example, high surface grades that have a low structure. So it's a multitude of grades. And the furnace process is so successful because it's quite unique. No other process can do that. No luck with, with controlling the slides. So why would we look at alternative carbons? We might want to have smaller particles. So we have the gas black process. This is for coloring applications. We go below 20 nanometer primary particle size, we have gas blacks. We want bigger particles. Maybe for AV applications, we go for thermal blacks, 990. This is made from methane, by the way, but pretty big particles, almost no structure, 300 to 500 nanometer primary particle size. Conductive, we might go for acetylene blacks. Then, because we're looking after sustainability, we might actually be concerned the The absorption capabilities of carbon black can be good, like UV absorption, but they can be bad as well, because black plastic cannot be sorted with near infrared. So maybe we can go for spinel blacks. So there's a number of, it's too small for me to read, but there's a number of pigment blacks that are spinel blacks that don't absorb near infrared light, so that the plastic type can be detected and the plastic can be recycled. We might want to have circular carbon black, so that's circular furnace carbon black. We might want to have recovered carbon black. Renewable carbon black, all these were already touched on today. We might want to have renewable fillers, biofillers, that wasn't mentioned today yet, for example, lignin and algae. And we might want to have methane blacks. Okay, so methane black overview. I find this space super interesting. Also, a quarter of us is here is carbon black. A quarter is selling machines. The third biggest group in here and the delegates is methane blacks, methane conversion. So basically we're decomposing methane into 75% mass carbon and 25% hydrogen. We need a certain energy. I have some 30 companies initially on the short list, but by now that has grown to 50 companies. This is a very, very dynamic industry. Safe to say that the major product, although 75% is the mass output, this industry thrives on hydrogen and the prospects hydrogen gives us for decarbonization. There's 12 companies with plasma technologies. That could be, for example, plasma arc, including, for example, a monolith. 7 companies are having catalytic processes, and there's a couple of companies that do liquid metal processes. I picked the 5 top companies on my list. Monolith clearly is the biggest by the production of methane black. And really, Monolith is the only company in my book that makes something I can call carbon black. There might be other companies next, so Graphos in Germany, Hycamite in the room, Levidian, I worked with Levidian, Hazer in Australia, and the variety of carbon materials is very diverse. It goes really from char over the carbon black, over to graphene, and we know graphene is not graphene, so is it 3 layers, is it 15 layers, over to multi-wall nanotubes, over to graphite. What is also interesting to me as a consultant and chemical engineer is these processes, and this is public data, maybe outdated public data because I couldn't disclose any data I might have from my projects. The energy to make these carbon products is much higher than just the decomposition energy for methane. So if you just use the decomposition, maybe you only get char. For higher structured carbons, we need to invest the energy. So you cannot beat the mass balance. That's what I'm saying to the recovered carbon black producers, and that's what I'm saying to the methane companies. Some in early contacts with me a couple of years ago actually said, we forsake the carbon. We just get rid of the carbon. We're hydrogen producers. But how can you forsake 75% mass flow output of your production? That is pretty stupid in my book. Graphene is not graphene is not graphene. That comes from John Hartley from Levidian. Also, hydrogen makes you sexy, carbon makes you money. And that I'm using for RCB as well. It's true the hydrogen is attractive, but really it's only when you make carbon black like Monolith does, and carbon black has an attractive price that you really ramp up the revenue. So some companies think the carbon, the valorization of the carbon is limiting the scale up. And they're thinking 50 million tons of carbon black is too small for them because the hydrogen market as of now is estimated at around 100 million, 110 million maybe. So we would have 300 million tons of carbon if provided we would have the whole world's hydrogen production just by methane pyrolysis. That will never happen. And these companies, I think they're thinking a little bit too big, and they're killing the birds in the egg. I think the carbon black market is a very attractive market for this industry. This is what I call the carbon landscape. You might know the oil absorption surface area chart for carbon black. These are carbon materials. It was a work I've done for a client. It's pretty small print, so you might not see the actual products. What I'm doing here is a double logarithmic chart of the price of the material over the volume, the market volume of the material. And we go all the way from mascara, which is a very small, expensive market. I talked about this in Carbon Black World Vienna as well, in a simplified version of that chart, all the way to coal, which is 8 point something billion tons per year market, obviously at a price, not very high. Now the question I'm asking the methane black industry is, do you want to be in the mascara market? So that would be the nanomaterials, and maybe only have 4,000 tons global market. Or do you want to be in a carbon black market, which is 15 million tons? Or do you want to be in a coal market? Because that's the level of commoditization, and that is the pricing and the volume you can achieve with your product. Sustainability. So with natural gas and normal grid power, we only have marginal improvements to standard furnace carbon black. But it can be greenified. So we can use biomethane. Monolith has presented about methane from swine manure, and we can use solar and wind power, and then we can be carbon neutral or even carbon negative. Recovered carbon black. Important to know, people talk about the tire pyrolysis industry. That industry does not exist. Recovered carbon black production is a three-step process, and it begins with the selection of the tire feedstock. We need to have a consistent feedstock, garbage in, garbage out. We need to control the pyrolysis process as well, and then we have the post-processing, typically milling, granulation, drying, packaging. Some companies have more elaborate processes, activation. I haven't seen ash leaching or inorganics leaching, and personally I don't really recommend it either. Top pyrolysis technologies, there's a big trend for auger, but the typical, let's say, low-tech technology is rotary. There's other technologies, for example, Circtec, Fluidas bed. Top companies, and this is by RCB capacity. I think Circtec have been overtaken by Pyrum now with the VTTI announcement, but it's the top 5 companies: Circtec, Pyrum, Boulder, LD Carbon, who just opened the second plant, and Eco Infinix in Thailand. Now, recovered carbon black means you cannot beat the mass balance. You cannot sell tire pyrolysis oil without selling recovered carbon black. To be fair, that counts also for the customer. Like a carbon black company taking in tire pyrolysis oil for circular carbon black. They should help the RCB producer and also take the RCB, because otherwise this company is squeezed. Also, TPO makes you sexy, carbon makes you money. And that is true for the pricing. We've seen many deals like Wastefront, also Circtec, are TPO motivated. For example, very interesting is sustainable aviation fuels, that was Wastefront, or renewable and marine diesel, Circtec, for example. And this is unlocking investment. However, when we look at the global crude market, 4.4 billion tons, it's very clear we'll never have enough TPO to replace all of that crude. If you say global tires is around 50 million, we got 20 million tons of TPO. If we add global plastic to that, that is 400 million. We still only have 420 million and not 4.4 billion tons of oil. So my recommendation is to be selective with what we do with TPO. Starbucks strategy. That's also one of my funny memes. Make the same coffee everywhere. That's the same, and that is really what will drive the RCB industry and the growth of the RCB industry. to have the same RCB. I just had a discussion in the pause with someone that said, no, we don't want the commoditization because then we're at the mercy of the buyer, at the mercy of the tire industry. So that might count for one player, but for the industry, certainly commoditization, standards, and making one type of RCB is key. Also, we haven't fully defined what is RCB. When I ask who is producing RCB, there's 2,000 companies in India saying, yeah, we make RCB. And we know there might be only 5 or 10 in India that really make a controlled RCB. Now, recovered carbon black issue. The good thing is we have been building the community over the years with the Recovered Carbon Black Conference. That now is a forum of almost 500 delegates split between RCB Asia and RCB Europe. So it's a big forum, and I think that forum has helped the industry to scale up. The problem is, you see the coffee machine there, where from one bean you get several coffees. It would be nice if we can choose the RCB we buy or the RCB we produce. So we got the community, but we don't have the specifications. Sustainability. There's two business paradigms in the world, and I would call it the Western world really drives on sustainability, and the Eastern world drives more on opportunism. And I wouldn't really be judgmental on it, which is better, because in the Western world, we make things way too complex. And in the end, it's very difficult to build something in the Western world. And in the Eastern world, maybe we have less regulations. People buy a reactor from China and they just get to business, maybe with low standards. But maybe halfway house between the two paradigms would be nice for the industry. One nice quote from Florent Ménégot, CEO of Michelin: "There is no ecology without economy." When I started as an RCB consultant, I was thinking like, yeah, RCB should be more expensive than carbon black because it delivers the sustainability and delivers semi-reinforcing properties. I think after 10 years, I would say we have to find a way to scale RCB cost competitive to carbon black. Typical data for the RCB, scope 1.5 to 1.2 tons of carbon dioxide, that should be equivalent per ton of RCB. That depends on the process. Some companies have double pyrolysis. Black Carbon is no longer with us, but they had a double pyrolysis. Scope 2, electricity, 0.2, which is pretty similar to furnace carbon black, I believe. Scope 3 then really depends on where the frame is. 0.09 for the L transport, and this is cradle to gate, so not from the factory to the customer. So total emissions 0.8 to 1.5, which is pretty attractive for emissions. Biofillers. We haven't been talking a lot about biofillers in this forum. I have some examples, 3 examples here. The process also, we need to prepare the feedstock. Even carbon black, we need to select the feedstock meticulously to get a good product. So feedstock separation, purification, and then we need to make the feedstock solid. Lignin is a thermoplastic material, so when we ramp up the temperature to rubber compounding temperature, 130 degrees, it will go all gooey and no reinforcement. So we need to make it hard. And then, of course, we need post-processing, maybe milling, maybe pelletizing, depends on the material. Some companies, UPM, are building a biorefinery in Germany. The capacity next year will be 30,000 tons, and the application is filler and pigment. This is a filler that is heavily hydroxylated, so it can be functionalized with silane, for example. Stora Enso, they also make lignin-based fillers, 5,000 tons capacity by end of next year, and this is more going into conductive applications into anode material, which is a very dynamic application, very interesting application right now. Very small production, 0.07 kilotons, so 70 tons per year, is living ink, and this is an algae black. So you can use algae, for example, for protein products, for food production. And then the rest you can pyrolyze and you can make a black pigment. That's what Living Ink does. And they're a very small company in the US, but they're working with all big brands, from Patagonia to Nike, Brooks, even Dior fashion brands. It's just fantastic. This, by the way, is a T-shirt I bought from them. BLACK is the brand, and this is with the pigments from Living Ink. And actually, I thought it will pretty quickly wear out, but the color is still there, so I love it. So biofillers, some data. Generally, we have low pH, low sulfur. We have also low, but not zero, near-infrared absorption. In the case of UPM RFF. Sometimes we have a kind of low carbon content, and that is because we have a lot of oxygen, we have a lot of hydrogen. The color, this is from my webinar, RCB in Plastic Master Batch, comparing jet black, signal black, and the color of the UPM biofiller, which is like a dark charcoal gray. So it's not jet black like the deepest black, like carbon blacks can do. But it is a nice story. Also, safe to say that consumers, I think they connect emotionally more with bioproducts than they do with circular products. You know, circular products, we think maybe it's dirty, it's something of lower value. Bioproducts, we relate to nature, so that conveys more positive emotions. Typical particle size, typical particle surface area is pretty small, less than 40 meters square per gram, but that is like on the eye level with the 660 carbon black. Sustainability, this is data from UPM. I was hoping to get data from Living Ink, but they gave me a negative scope 1, and I couldn't make sense out of that because scope 1 for me is the production and is always like a positive, unless you put the algae production, which has carbon capture, into the scope 1. So this is UPM. Biofiller feedstock, of course, captures CO2. And biofillers can be CO2 neutral or even CO2 negative. And these are values. UPM with a total CO2 equivalent emissions of minus 1.1, which is kind of attractive. So, summary, methane black, recovered carbon black, biofillers can offer added value to raw material portfolios. All three fillers can replace semi-reinforcing carbon black, so in the same market. And that's why we see methane carbon producers in this forum, but also in the recovered carbon black forum. And we see UPM also in the recovered carbon black forum. So applications are rubber, some carbon specifically targets coloring. Coming back to the engineering, there's a very high degree of engineering required for manufacturers of these alternative carbons if you want to replace carbon black. Production volumes are small, but they're growing, and the supply chains, we know it takes years and years to build supply chains. Supply chains are being built. Thank you very much. And by the way, that's a picture from Moving On Summit from Michelin, which is putting me in the year 2035. So maybe I did too much work in RCB.
You still look great, even in 2030.